Alright, we're going to talk about the second gas law that we did not talk about yesterday, which is Jacques Charles. He was around from 1746 to 1823. He was a French scientist, and he was famous for taking the first solo hot air balloon ride. So that's what made Jacques Charles famous. He was also famous, of course, for his gas law, which was this equation here, which is V1 T1 over V2 T2. And basically he said that if you have a volume of gas and it goes up, then the temperature also goes up. Now the big thing with the Charles law is that the temperatures must be in kelvins, which means that if you have a Celsius temperature, you must add the 273 to it. And of course we've already done that this year, so you should feel somewhat comfortable with that. So let's just look at some examples of how to use Charles' law. So you have these on your notes that I gave you yesterday. So here we go. So of course we're going to use Charles' law, so we'll write that at the top. So you have that. So V1 over T1 equals V2 over T2. Okay, and so that means I'm going to need V1, I need T1, I'm going to need V2, and I'm going to need T2. Alright, so they give me a 2-liter balloon at room temperature, 20 degrees Celsius, and they tell me they're going to put it in a refrigerator, and they want me to figure out the new volume after it cools. Okay, so they give me a 2-liter balloon, so that's going to be my first volume. Okay, and then they give me a 20 degrees Celsius, so that's going to be my temperature. So notice that those two numbers came together, so they're my ones. And then they give me 3 degrees Celsius, so there's a second temperature, so that's going to be my second temperature, so that's going to be my 2. And then I do not have a third volume, so that's going to be V2. Alright, so I'm solving for V2. Now I have these two temperatures, so of course I have to add 273. So 273 plus 20 is 293. Oops. Okay, and add 273 there. 276. Okay, so there's all my numbers because I have to have my temperatures in kelvins. So now I'm ready to set this up. So I have 2 over 293 equals V2 over 276. So now it's just a matter of I cross multiply to solve. So 293 V2 equals cross multiply. So I have to take 276 and multiply it by 2. So 276 multiplied by 2 is 552. And now I just have to divide each side. Treat it just like, that was an x. So I want to solve for x. So divide 552 by 293. So V2 is equal to like 1.9. And so it's a volume, so my volume is liters. Okay, and so that's the first example. Alright, so let's do another one. Okay, what would be the final size of the balloon in the previous example problem if it were placed in an 18-degree freezer? So again, we're still using that same equation. V1 over T1 equals V2 over T2. So V1 T1 V2 T2. Okay. And so they gave us, in the last one, they gave us 2 liters. They gave us a temperature of 293. And now they're asking us to change that temperature to -18. And this is why it's so important for us to put our temperatures in kelvins, because that negative 18 would really mess up our calculations. So now we're going to add 273, or basically take 273 and subtract off 18. So 255, and find V2. So now it's just a matter of taking 2 over 293 equals V2 over, in this case, 255. And we can find what that new volume is. Again, cross multiply, 293 V2 is equal to 255 times 2, which is 510. Divide each side by 293. 510 divided by 293 is V2, which is 1.7 liters. And that's it. That's Charles' law.